Hey everyone, this is Dr. Walker. This is video 91 on sound waves. Now we could spend a whole chapter on sound, so I just want to focus on a few topics in this video. First of all what is a sound wave? A sound wave is produced by vibrations of matter and it does require a medium. Sound cannot go through a vacuum. I like to show this picture of opening a window quickly and imagining it compressing the air and pushing the curtain out. And then when you shut the window quickly, there is what is called a rarefaction, and now the curtain comes in. So if you do this back and forth, you're going to get a series of compression and rarefaction, and they're going to keep alternating. And this is the wave that propagates, and this is sound. Sound is also called a pressure wave because it alternates between these highly compressed areas and then these areas that are not compressed, the rarefactions. Sound is a longitudinal wave because the particles that move, the air, they move horizontally if the sound wave is traveling horizontally. The next thing is about the speed of the sound. Speed does depend on temperature, and we have an expression here to find the speed of sound at any temperature. The speed is equal to 331 times the square root of 1 plus the temperature in Celsius over 273. If we use this expression for a temperature of 0 Celsius, we'll see that the speed of air in sound is 331 meters per second. But typically, we are dealing with a problem that has room temperature, which is considered to be 20 degrees Celsius. So you plug in 20 degrees Celsius in here, and you'll get 343 meters per second. So that is the speed that we usually use for sound. The next thing is about pitch and intensity of sound. So pitch has to do with frequency. Sound is perceived as being of higher pitch when the frequency is higher. Intensity, however, deals more with loudness. Sound that has a larger amplitude is perceived as louder. You can look at this longitudinal wave and you can draw it as a wave with crests and troughs, with crests corresponding to the compressions and troughs corresponding to the rarefactions. If you have a bigger amplitude, a lot more areas of more compression or more rarefaction, then that is going to be a more intense sound. The intensity is interesting because that's what we're used to, and that's what we perceive when we're listening to sounds and how loud they are. So let's define the intensity of a sound as the rate at which the energy flows through a unit area. The rate at which energy flows is the power, so power per area. If we imagine a source of sound, then the further away that we are from that sound, the less intense it's going to be, because you can see that those sound waves are spread out over a larger and larger area. The units for power are the units for intensity are watts per meter squared. The thing about the human ear is that the sensation of loudness is logarithmic. So we need a different scale. Now what this means is that as far as the sound being logarithmic, this means that if there's a sound that's increasing in intensity and we want to perceive that change in intensity, that sound needs to be doubling every time for us to notice that change in intensity. This allows us to hear sounds that have very, very low intensities and very, very high intensities because of the way that our ears function. So we have a different scale to measure the intensity level of sound. It's called a decibel scale. It says that to convert a sound to a decibel level, we take 10 times the logarithmic of our intensity of our sound divided by this reference intensity I0. This reference intensity is considered the threshold of hearing. It has a very, very small value, 1 times 10 to the negative 12. So we're comparing the intensity of the sound to that reference intensity and using this logarithmic scale. Here's a result of typical sounds and their decibel levels. Threshold of hearing is 0 decibels. Threshold of pain is actually here around 130 decibels. But you can see how the increase in loudness of each of these sounds correspond to an increase of 10 or 20 decibels each time. Let's go ahead and look at an example to understand the scale a little bit better. Increasing the intensity of a sound by a factor of 100 causes the sound level, this is the decibel level, to increase by what amount? So all we have to do is plug it into our equation for this sound level or decibel level is 10 times the log of our intensity over our threshold intensity or reference intensity. So we're increasing the intensity by a factor of 100. So we can say that I over our reference intensity is going to be 100. This ratio is going to be 100. So we don't have to compare it to the threshold intensity if we're just looking for the increase in decibel level. We can compare our intensity to any other level to see what the decibel increase is relative to that reference intensity. So in this case, our intensity is 100 times this reference intensity. You just do 10 times the log of 100, and we will get a decibel level equal to 20 decibels.